In this section, we're going to be defining congruent figures, and we're also going to be looking at their corresponding parts. We're also going to have a lot more proofs that follow from this. So we'll be looking at a few proofs and how to use proofs, how to use the theorems we're learning about to prove that figures are congruent. Now, the first thing we want to define congruent figures, we want to think of them as figures that have the same size and shape. And even if we slide them around or turn them or flip them over, we can still match parts that go together. Like these two angles here would go together, and these two here would go together. And so congruent figures are going to have matching parts. So that's just our definition of congruent polygons, is that we have corresponding parts. And notice how all this is written out. A to B is the same as F to E. C to D is the same as G to H. And notice how these parts are, both those are opposite of each other. The BC and the FG correspond with each other, and the DA and HE. We also have matching angles as we go around. A to E are both matching. Angles C and G are going together, and D and H. And notice then that those angles end up going around in the same order. Also notice the way that we name congruent figures. They're always named with the matching parts together. So since A matches with angle A and angle E are the same, they both go first. So if I call the first one A, B, C, D, when I name the second one, I'm going to go around in that order. A goes with E, B we look up, B goes with F, so F goes next. C matched with G, so G goes next. And then finally D and H go together. So if we want to find congruent parts, they might give us a name like this, and even though they've given us a picture over here, we don't even need to look at the picture because the name is enough to tell us what matches. If we look at HI, it's going to go with LM because they're in the same position. If we look at IJ, the two middle letters are going to go with MN. The two last letters, JK, goes with NO, and so on. The last and first letters, KHOL. And in the same way, the angles are going to match up. H to L, I to M, J to N, K to O. Now if they give us a figure and ask if they're congruent, and they ask us to justify the answer, we have to consider all the parts. Now here I've listed out the parts that we want to be congruent. So we have AB congruent to ED. So we need to look at our figure. Is that true? AB and ED. Notice that both of these are marked as congruent. So that's just given to us. If we look at BC and CD here, or DC, we have to do a little bit more work. We're going to notice that they're both equal to 4. By the definition of congruence then, they're also congruent to each other. Same thing with AC and CD. We notice in the picture they're both equal to 6. Therefore, by the definition of congruent segments, they are congruent. In the next one then, we look at our angles. A goes with E, B goes with D. Those are just marked again, so those are given. Now the final one we're going to have to do a little bit more work, but if we notice their location on the picture, those are vertical angles, and vertical angles are always congruent. So since we look back, we've got all 6 parts, all 3 pairs of sides, all 3 pairs of angles for those triangles, then we know that they are congruent by the definition of congruent triangles. This next theorem follows from chapter 1, the third angle theorem. Remember that we know that all of the angles add up to 180 degrees. So what this is saying, if we know that A is congruent to D, B is congruent to E, that means that the third angle has to be congruent. Now to prove this theorem, we'll start by being given 2 angles, so those are marked A and D, B and E, and basically the idea is if all of these need to add up to 180 degrees, and we know what 2 of them are equal to, then we should be able to show the third one's equal. So let's just start with our given information. And then we're going to change these to equal because we're going to be using plus or minus here in the 180. And we can do that just by using the definition of congruent angles. The definition of congruent angles was that we get measures that are equal. And then we're going to use our angle sum theorem from last chapter. So in our first triangle, A plus B plus C gives us 180. And in the second one, D plus E plus F gives us 180. Now, this is where that last step comes in. Why we wanted these to be equal to each other, because we'll be able to do some substitution soon. Notice both of these are equal to 180, so we just leave that out and skip down by substituting. We've got A, B, and C. Now again, we know about A and D being congruent, B and E being congruent. And so we do another substitution here where A becomes D, B becomes E. Now we have that D and E on both sides, and if we subtract it away, we're left just with the C and the E. So here we've got this on both sides. All that's left is the C and the F. Now our proof has to show they're congruent, not equal, so we do need to go one more step, change those measures being equal to each other to showing that they're congruent to each other, which is again a definition of congruent angles. Now we can use that. If we know two angles, we know that the third one is also congruent, and we're going to use that in this next proof. Notice first of all that our given information here, it is already marked on our picture, but we can double check that. LM and LO with 1 mark, MN and ON with 2 marks. Then our angles, M and O with 1 mark, and angle OLN and MLN here are congruent. So what we need to show these two figures are congruent, we need to match all 6 parts here. 3 sides, 3 angles, but we only have 2 sides and 2 angles. So first let's go ahead and list our given information. Then the next part is to notice that the side LN is actually congruent to itself. This is the same side, and that's the use of the reflexive property. And we do need to say that because to show figures are congruent, we need to show that all of the parts are congruent. Okay, next we have our given angles. And if we have 2 angles congruent, based on this last theorem that we just proved, we know that the third angle would also be congruent. That's the third angle theorem. And then finally we look back, okay, I've got all 6 parts matched. I could go ahead and mark those also in my original figure. And so I can say the two figures are congruent by the definition of congruent triangles. Now also it's good to go back and double check to make sure that you've actually named this correctly. The L goes with L, M goes with O, and N goes with N. And we can see that from our angles.